Okay, so good day everyone. Today we're going to discuss about the stack and queue data structures. First of all, let us talk about stacks. In real life, a stack may refer to a file of things like a stack of cards or a pile of papers. It is interesting to note that a stack data structure can just be imagined as such. It is simply a pile of subjects or objects. Think of a container. The object to be put in a stack will be put into the container, with the very first item at the bottom and the last item to be put at the top. Because of this, stack data structures are also called LIFO, LIFO, or last in, first out. The last item we put on the stack will be the first item we will be getting from it. Stacks are used in a wide variety of applications. Several of the programs we use include a form of undo-redo system. This relies on stack to keep track of the last thing the user did so that it knows what to do remove when the undo function is invoked. This may be seen in the word processors, auto manipulation softwares, and others. Another application is in function recursions. This occurs in programming when a function is designed to call itself. Every iteration of the function means another addition to the stack of functions. Once a specified condition is met, the recursion stops and all the function calls in the stack will be removed one after another, starting from the last function instance to be called. Another interesting idea is that the items in a stack can simply be thought of a list. What makes the list different are restrictions, which classifies this a stack. New elements can be added to a basic list virtually anywhere, but with stacks, we restrict ourselves to be only adding items at the start of the list. Any item can be accessed and removed from a basic list, but stacks only allow this process at the very start. These basic operations are formally called a push and a pop. The concept is very simple. The push means adding a new object to the stack, and the pop means removing the topmost item from the stack, as you can see from the picture. Now, in actual coding, the programmer has the options by which he or she can implement a stack data structure. They can make use of either arrays or linked lists, two of the more basic data structures we have discussed before. The array implementation makes use of arrays to hold the actual values of the stack. It can be thought of just a simple list, but the adding and removing of elements are restricted to only one end of the list. This is an example of Python program of a stack using an array implementation. Now, as you can see, in arrays, the identifier for the top of the stack is an index number. Then array name, then -1 or -1. The top value is the last element in the array. So, as you can see from the program, the sole attribute of the class stack array is an array self_underscore array that is for the that is for keeping your variables or your array private. Thus, all the rules of the arrays apply to the creation of such. Of particular note are the push and pop operations of this implementation, which makes it different. As previously defined, these operations manipulate the value at the top of the stack. This top can be interrupted in different ways. For this particular code, the top of the stack is at the end of the array. Several arrays implementations of stacks do it in this way. Because of this, push and pop can just become a redefinition of the append and built-in pop methods for arrays, the latter of which manipulates the last value of the array by default if no index number is specified. Now you can see the output of this code. Do note that the arrangement of the values of the array is reversed when printing, as this looks nicer and is much more intuitive. Another implementation of a stock data structure is by using linked lists. It is more or less the same as the kind of linked list we have tackled prior, only with the added restrictions which makes it a stock. New nodes are added at the beginning of the linked list, modifying the head node. This is because such an operation is faster than adding to the end of the list. The array implementations makes use of index numbers while the linked list use nodes. This is a sample Python program of a stack using a linked list implementation. As you can see from the code, the push method sets the node to be added as the head node and sets the pointer of this node to the previous head node. The pop method rearranges the pointers. The node next to the current node will be set as the head. The old head node may be simply disregarded or deleted from the memory. Now you can see the output of this code as follows. Now let's talk about queues. Almost every day we encounter queues. Think of the long lines in transport terminals which must be followed to get on a public transport vehicle. Queue data structures are simply just that too, a series of objects. As you can see from the picture, what makes queues different from stock is the kind of restriction it has. Stacks are limited to inserting and removing items from one end only, whereas in queues, insertion of elements occur at one end and the removal at another. Because of this, queues are sometimes called FIFO, FIFO, or first in, first out. The insertion end is called the rear or tail, and the removal end the front or head. Stacks have push and pop as their basic operations. Queues have similar methods to these two called enqueue and dequeue. In fact, they are virtually the same. It's just that the enqueue method will operate at the rear end of the queue and the dequeue at the front. Now, here in the picture, the concept of queues can also be seen in different instances. For example, printers can handle multiple printing requests one at a time. The first request received will be the first one proceed, and the succeeding ones will be put in a queue. In this picture, another instance of queue is when calling customer service hotlines. If a staff is not yet available or is currently processing somebody else, a caller will be put on hold until someone can attend to him or her. And in this picture, as with stacks, queue data structures can be made with either an array or linked list implementation. In an array implementation, the array represents the actual queue. It is up to the programmer to designate which part of the array will be the front and the rear. In the following sample, Python program based on the front will be the first element of the array, and the rear will be the last. As you have seen the code, because of the way the rear end was designated, the enqueue method ended up looking like just a redefinition of the append method for arrays. For the front, however, we had to specify the index number of the first element in arrays, which is 0. This is because of the pop method, without specifying an index number, defaults to modifying the last element of the array, a behavior which we have demonstrated in the array implementation of stacks. You can see the output of the shown code is as follows. Four values 0, 1, 2, and 3 were added to the queue. A value was dequeued, then another value 5 was enqueued. Finally, two or more were dequeued, leaving only 3 and 5. With a linked list implementation, you can also use the idea used in an arrays to complete the build. Think of each element in an array as the nodes. In linked list, the first node is called the head, and the last tail. We will be designating them as the front and rear ends, respectively for convenience. This implementation is also made distinct from that of stocks because now we need an identifying variables for the tail end. Basing from the example provided, the following is sample Python program of this implementation. Now in the code, the enqueue method assigns the node to be added as the tail node. It also points the current tail node, if present, to this node. If the linked list is empty though, the tail node and head node are essentially the same and are set as such. The dequeue method sets the second node in the list as the head node and sets the current head node as its return value. If the linked list is empty though, it will print a message stating such. This is the output of the code. You can see. For values 1, 2, 3, and 4 are added to the queue. 2 were dequeued, leaving 2 and 3. To sum it all up, what we have discussed in this video is all about the stack and queue data structures. Both can be implemented using arrays and linked lists. They also have a pair of basic insertion and removal operations. Push and pop for stacks and enqueue and dequeue for queues. The logic for these operations are pretty much the same, excepting for integrating the restriction sets on each data structure. For stocks, both insertion and removal occurs only on one end, hence having the name last in and first out, whereas in queues insertion happens on one end and removal on another, hence first in first out. In an array implementation, the ends are designated by an index number, whereas in a linked list implementation, the ends are designated by the head and tail nodes. That is it for today. So I hope you have added more knowledge about data structures. Stay awesome and get coding. Think twice and code once. Good day, everyone.